Ladies and gentlemen, boys and girls, children of all ages, when you entered the room, you had these problems to work on. You have them in your journal right now. My advice to you is to follow along in your journal to make sure they are correct, because you may or may not ever see them again. I'm being very specific when I say may or may not. You will never know, one way or the other, whether or not you will see them again. It's a complete secret. So let's look at the first one. We have 670 times 88. The first thing I'm going to do is I'm going to write it vertically, not horizontally. So computers are closed, your journals are open, you're following along with this. Thank you. Then I'm going to estimate. I'm going to say 670 is close to 700, 88 is close to 90. I can take my 3 zeros, since they're at the back, trailing zeros, put them down at the bottom. Then I just have to know 7 times 9, which is 63. So my answer should be somewhere in the 63,000s, 50-something thousand, 50 or 60 thousands. If your answer's not anywhere near 50 or 60 thousands, then we've probably messed up somewhere. So then I have my original problem, 670 times 88. Now, because I want to be fair and I want to show everybody everything, we're going to break it apart and do 670 times 8, because this 8's in the ones place, and then 670 times 80, because this 8's in the tens place, and 10 eighths equals 80. Now this is very similar to one of the problems you had to do on the warm-up yesterday, and the reason I picked this is because it's very similar to one of the problems you had to do on the warm-up yesterday. Alright, so now I need to know my multiples of 8 is all I have to know. If I don't know it, I can look at my multiplication chart, because unless we're taking that stupid state test, then you can use it in my classroom. So I use my 8s. 8 times 0 is 0. 8 times 7 is 56. So I have 56 tens. So that means I keep 6 tens and change 5 of those to 500s. And then we have 8 times 6, which is, how much? 6 times 8 is 48, plus 5 more? 53, okay. I almost had to take off my shoes. So 670 times 8, 5,360, as long as I did my math correctly and Michael didn't lie to me.
Wait, that's the answer?
No.
Okay.
That's 670 times 8. But what I wanted to try and prove to you yesterday when we did 3, 4, and 5, and you did 9 multiplied by 99? No, it was by 90. Instead of 88, you multiplied by 99. 80, I'm still just multiplying by 8. The only difference is this number's in the ones place. Because since I'm starting in the tens place, then I have to have that extra digit. So then I'd have 53,600. All I did is take this, because it was 670 times 8. This one, 670 times 80. I don't need to do the multiplying by 8 again. I already did that. It's right next door. So now I have these two numbers. So when you were doing that assignment yesterday, if you missed 3, you should have missed 4. And then you should have missed 5. Actually, you shouldn't have missed any of them, because there was a video on the Classroom of Google that you could have looked at. And then all I have to do is add these two together. 53,600, 5,360. Because that's what I'm going to get when I do the actual algorithm. And so your final answer, as Regis would tell you, 58,960. That would be your final answer. And I'll post this on the Classroom of Google today so that you'll be able to watch, and I'll do a video in each class so you'll be able to watch. And I'll find my eraser so you'll be able to watch. Donde está mi eraser? Aquí. Alright, so let's look at the second one. 625 times 31. 625 times 31. First I'm going to estimate. I'm going to say this is 600 times 30. These 3 zeros that are trailing, I just move them down. So I have those 3 zeros moved down. I don't even have to do the multiplication. And then all I have to know is my 3 times 6, which is 18. So my estimate is somewhere around 18,000. My estimate is somewhere near 18,000. So now I can do 625 times 1 and 625 times 30. Because I'm doing 31, so if I break it apart, I have 30 and I have 1. 31. And I'll go over the standard algorithm and show how these tie together. Oh my gosh, I hate multiplying by 1. 625 times 1 is?
625.
Oh. I was going to add and make it 626, but that'd be wrong. Now I have my trailing 0 here, so that means I'm starting in my tens place, which means I don't want to put anything in my ones place. So there's no ones. So I have to put a 0 because there's no ones. Then I do 3 times 5 is? 15. So I have 15 tens. I'm going to keep 5 of those tens and trade 10 of them in for 100. 3 times 2, 6, plus 1, 7. 6 times 3, 18,750. Now if I go over here and I use the standard algorithm, and I take my 1 times all that, that's where my 625 comes in. Because 1 times 5 is 5, 1 times 2 is 2, 1 times 6 is 6. So that's exactly what I just did over here. I just moved it over so I didn't have to look at all that stuff, and it looks all cattywampus to me. Then, so I'm done with my 1, I'm going to start in my tens place. So that I have 0 in the ones place. So I'm going to put 0 in the ones place. Can't just leave it blank, that's crazy. What are y'all thinking? And then I do 3 times 5 is 15, 3 times 2 is 6, plus 1 is 7, 3 times 6 is 18, which is exactly what I got over here when I multiplied by 30. Then I add those two things together, and I get, let's see, 5, 7, 13, 9, 19,375. As long as I did my math correctly and you did your math correctly, otherwise you'd yell at me and say I did it wrong. And then last and certainly least, we have 2 4/10 times 16. I want to estimate this first. So if I say 2 4/10 is close to 2, and 16 is close to 15, what's 15 times 2?
30.
30. My answer needs to be somewhere near 30. My answer needs to be somewhere near 30. Now, when I do the problem, I'm going to ignore the decimal points, and I'm going to make it 24 times 16. And I'm just going to do the standard algorithm on this. 6 times 4 is 24. 6 times 2 is?
12.
Plus 2 more?
14.
14. Now I'm on my tens place, my 1. So I put my 0 there. 4, 2, 4, 8, 3. Now, how many numbers are behind the decimal point in my problem?
1.
1. Just one number behind the decimal point in my problem. There needs to be just one number behind the decimal point in my answer. Does it look somewhere near? It's somewhere near. I mean, I rounded them both down, so obviously my estimate's going to be lower than the actual answer. Questions? Awesome sauce. All right, boom shakalaka, peace out, God bless, love you, do something kind today, save the bees. Keller GBB. Subscribe to that, subscribe to me.